All right, y'all. Last lesson here. Last lesson before that final exam. We can do this. All right, here we go. So this last lesson is on rates of change in tangent lines, day 2. Okay, so it's the second day of it. So before we start today's lesson, there's a few things that you need to know. First off, the formula for the equation of a line, which everyone knows. We're using point slope form, not slope intercept. So not y equals mx plus b. We use y minus y1 equals m times x minus x1 because you can use any point with this. You don't have to use the y-intercept. Next, definition of a normal line. So we have to know what normal line means. Normal line is the same thing as a perpendicular line. So if I said name a normal line, or if you look here, it says write the equation of a normal line. It's a line perpendicular to the original line, okay? All right, so also what you need to know is that these three things are synonymous, meaning they mean the exact same thing. So slope of the tangent line at a point, slope of the tangent line at a point means the same thing as derivative, which is the same thing as the instantaneous rate of change. And we're using the limit definition of the derivative to do this. So you use the limit definition to do all three of these, okay? And they all mean the same thing. So here's our first example. I give you the equation y equals x squared plus 1. Find the equation of the slope of the tangent line. So this is find the instantaneous rate of change, or find the derivative. We already know how to do that. That's yesterday's stuff. So we're going to say y prime is equal to the limit as h approaches 0 of, I need f of x plus h. So remember, I'm plugging in x plus h there. So x plus h quantity squared plus 1 minus, putting brackets around that, f of x, x squared plus 1, all over h. Okay, so now I'm going to expand that. Limit as h approaches 0. And then that's x squared plus 2xh plus h squared. Don't forget the plus 1 that was right here. Distribute your negative, minus x squared minus 1 all over h. Clean up your numerator. Negative 1 and positive 1 cancel. Negative x squared and positive x squared cancel. Limit as h approaches 0 of 2xh plus h squared all over h. Factor out the h out of the numerator so you can cancel it with the h in the denominator. Oh, one thing that's really important that I want to state now, because if you do this, you're going to get points taken off. You're not allowed to go like this. Okay, that's not how you simplify a fraction, right? We simplify fractions by factoring them and then canceling out any common factors. So I'm going to factor out the h. It's 2x plus h left all over h. The h is canceled. That's how you simplify it. And now you can plug in 0 for h, and you get 2x. Okay? So the slope of the tangent line is y equals 2x. Okay? Or sorry, y prime equals 2x. Okay, so next it says find the slope of the tangent line at the point 1, 2. So this is generic right here. This is the slope anywhere, okay? These are all specifically find it at 1, 2. That means at 1, 2, what is the slope, okay? So to get a better idea of what we're talking about here, let's graph this parabola here, y equals x squared plus 1. So I know the y-intercept, or it's not y, well, I guess, yeah, it's the y-intercept, but I know the vertex is 0, 1. And then if I plug in 1, I get 2. So that means if I plug in negative 1, I get 2. And if I plug in 2, I get 5. And it's symmetric here. Okay, so this is what my parabola looks like. And this first problem here, this B right here, it's saying find the slope of the tangent line at the point 1, 2. So let's find the point 1, 2, which is right here. I want the slope of this tangent line right here, the line that's tangent at that point. So it's asking me what's the slope of that line. Okay. All right, so what we're going to do to find that is realize this is an x value. We are going to plug the x value into our equation. So we have y prime of 2 times 1. Or I should say, I'm plugging in 1, so I should say y prime of 1 because I'm plugging in 1. And I get y prime of 1 is 2. So the slope is 2 there. If you look up 2 over 1, it's pretty accurate. My line I drew is pretty accurate, which is shocking to me. Okay, let's move on to C. Write the equation of the tangent line. So remember, to write the equation of the tangent line, you need two things. You need a point, ba-boom. You need the slope, voila. So now I can write my equation of my line. Y minus y1, which is 2, equals m, which is this 2, times x minus 1. So I was using this for x1, y1 right here. Easy, right? Next, write the equation of the normal line, so a line perpendicular to this. So if this slope is 2, the perpendicular slope is the opposite reciprocal. So y minus 2 equals negative 1/2 times x minus 1. Super easy. Okay, same thing done here. So let me switch colors. Let's do blue. I want to find the slope of the tangent line at negative 2, 5. So negative 2, 5. Draw my line. Oh, goodness. Draw my line right there. Oh, I'm trying. Okay, so I want to find the slope of that line. All right, plug negative 2 in. So we're going to find y prime of negative 2. So that's 2 times negative 2. And that means the slope at negative 2 is negative 4. And if you look right here, it's pretty spot on my drawing. Down 4 over 1. Okay, write the equation of the line tangent. So you have your point, x1, y1. You have your slope, which is negative 4. Y minus 5 equals negative 4 times x minus a negative 2, so plus 2. Write the equation of the normal line. Remember, normal line's perpendicular, so what's the opposite reciprocal of negative 4? It's 1/4. So y minus 5 equals 1/4 times x plus 2. Okay? All right, so that is the gist of the lesson. So now we will do 2 more problems. That's it, 2 more problems where it's asking you to basically do the same thing. Okay? All right, so the directions here, find the equation of the tangent line and the normal line. So I want to do part C and part D here. So this was baby stepping you through it, this warm up here, and then this is the same idea. Okay, so first off, I need to find the slope anywhere. To find the slope anywhere, I use the limit definition of the derivative. Okay, so I'm going to do the limit as h approaches 0 of, I need f of x plus h. So I'm plugging in x plus h right here and here. So I have 4 times x plus h quantity squared plus x plus h minus f of x, which is 4x squared plus x all over h. All right, now I got to clean this up. So I have the limit as h approaches 0 of, that's 4 times x squared plus 2x h plus h squared plus x plus h, and then distribute your negative here. So minus 4x squared minus x all over h. Once again, I like to distribute the 4 right above this so I don't have to make an extra step. So 4x squared plus 8xh plus 4h squared. Cross this off like it was never there. And now I have, I can simplify my numerator. So I have negative x and positive x. I have negative 4x squared and positive 4x squared. So now I have the limit as h approaches 0 of 8xh plus 4h squared plus h all over h. I'm going to factor an h out of everything in the numerator. So that's h times 8x plus 4h plus 1 all over h. Those cancel. And now I can plug in 0. So this is going to give me the slope anywhere, the derivative. All right, so I'm going to plug in 0 into this now, for h that is, and I get 8x plus 1. So that is the slope anywhere. So now I can find the slope anywhere I want. Okay? All right, so let's find this. Where do I want to find the slope? I want to find it at -1. So let's find the slope at -1. Plug in -1. I have 8 times -1 plus 1. And I get, that's -8 plus 1, which is -7. So the slope there is -7. Okay? Now I want to write the equation of my line, so I need a point on the line. I didn't give you a point on the line, but I gave you an x value. So you can find a point on the line by plugging in that. Technically, you can plug in any x value, but no, not any x value. You'd have to plug in that -1. So we also have to find f of -1. So I think on the next problem, I'm going to start by doing that so I can find my point right away. So that's 4 times -1 squared minus 1. And that is 3. So that means that there is a point at -1, 3. So that means that there is a point at -1, 3. So now I can do my two things. I can write the equation of my tangent line. So tangent line y minus y1, which is 3, equals m, which is -7, times x minus x1, which is -1. So I'm going to change it to +1. Okay, now I can also do the normal line, which is just perpendicular to that line. So y minus 3 equals +1/7 times x plus 1. And there's my two lines. Not too shabby, right? Okay, let's try one more right here. So I need to write the equation of the line. In order to write the equation of the line, I need to find the slope. So I need to get the slope anywhere, and I also need a point. So let's start by getting the point that we're going to use. I know it's -3 comma something. So let's plug in -3 here. F of -3 equals -3 squared plus 2 times -3 plus 1. That's 9 minus 6 plus 1. So 4. So there is a point at -3, 4. So point is -3 comma 4. Okay, so now let's find the slope anywhere. So slope anywhere is the derivative of f. So that's the limit as h approaches 0 of f of x plus h. So I'm going to plug in x plus h here and here. X plus h squared plus 2 times x plus h plus 1 minus f of x. I'm just going to copy that down. X squared plus 2x plus 1 all over h. All right, let's clean this up. Limit as h approaches 0 of x squared plus 2xh plus h squared plus 2x plus 2h plus 1, and then distribute your negative here, minus x squared minus 2x minus 1 all over h. All right, clean up my numerator. -1 and +1 cancel. Notice I work from the right towards the left because I know those three things are going to cancel out. -2x and +2x. If they don't, I also know I made a mistake. -x squared, +x squared. All right, so now I'm going to write what I have. Limit as h approaches 0 of 2xh plus h squared plus 2h all over h. Simplify the numerator, or not simplify the numerator, I'm sorry. Factor the numerator, factor out the h. H's cancel, and now I can plug in 0 for h. So this is going to give me my derivative, or the slope anywhere. So if I plug in 0 here, I get 2x plus 2. So that's the slope anywhere. I want to know what the slope is at -3, right? Because it told me at x equals -3. So now let's find the slope at -3. So I'm going to plug in -3 here. 2 times -3 plus 2, which is -4. Now I can write my two lines. My tangent line and my normal line. So I have y minus y1, which is 4, equals m, which is -4, times x minus x1, which is a -3, so plus 3. Normal line is just perpendicular to that. Y minus 4 equals the opposite reciprocal of -4 is positive 1/4, times x plus 3. And there's my two lines. Okay, that's it for today. We did it. We got through this. You can go ahead and get started on your homework. Your homework is a final exam review of Chapter 3 and Chapter 12. It will have stuff like this on it. When you're done with that, you can check all your answers, and then you're going to be ready for your final exam. Don't forget also that if you haven't completed your Chapter 10 final exam review, which was from Monday or Tuesday, depending on what your class was of last week, make sure you have that complete too. All right, have a